Hello, folks. So, welcome to part 7, and now we're actually going to compare the guess to the secret number. This is part 7 of learning Rust from scratch. And now that we have user input and a random number, we can compare them, right? So, we have the user input. So, the random number or the secret number is here, and secret number and the user's input or the guess is here. And so that step is shown in listing 2.4. Note that this code won't compile just yet, as we'll explain. Why is that? Okay, well, let's look at it. So they have included ordering, and let's just include ordering. Um, this is this is unnecessary, but it never removes it anyways. So you guessed, oops, and we put that in, and we're gonna match. Why won't it work? I wonder. So let's see if there's an error. Why found expected reference string found integer. Okay, so basically mismatch types expected reference is string found integer. So basically we're comparing. A string with an integer because we took the guess as a string. So yeah, we'll have to probably look at how we can deal with this. So compare is actually you know I think a function defined on the type string. So I am going to look at implementation of string and see if we can actually find this. It says derive, so equal, so this should be under equal, I think. Equal have to compile a built-in, okay. Partial equal, partial ordering, order, interesting. Something to check out where the code is for this. Um, I'm guessing there must be an implement string. Yes, there is. New, and then can I find a CMP here? No. Cool. So basically, CMP is present in string, yes, just about string. And I think attribute macro, so it's a derive is a macro, and used to apply derive macros. See the reference now. For more info, okay. So attribute allows new items to be automatically generated for data structures. It uses meta list paths syntax to specify a list of traits to implement or pass to derive macros to process. For example, the following will create an implement item for the partial, equal, and clone traits for foo, and the type parameter t will be given to the partial, equal, or clone. So for the appropriate implementation. Okay. Generated implementation for partial is equal to interesting. So this is a generated implement. So you can implement derive for your own traits through procedural macros. So I'm not sure what these are, but the proc macro derive, I think procedural macro. So these are something to learn from. I think I'll put this in here in reading. Okay. And let's go. So so it won't compile. Yes. First, we add another use statement, bringing a type called ordering. So I think it's an enumeration in the scope from the standard library. So CMP, I think, is short for compare. So the ordering type is another enum and has the variance less, greater, equal, which makes sense because we are trying to match the result of this with less, greater, equal. If it's less, this, greater, equal. So these are the variants here. So values, variance. So these are the three outcomes that are possible when you compare two values. Then we add five new lines at the bottom that use the ordering type. The CMP, the compare method, compares two values and can be called on anything that can be compared. It takes a reference to whatever you want to compare with. Here it is comparing guess to secret number, then it returns a variant of the ordering enum we brought into scope with the use statement, and we use a match expression to decide what to do next based on which variant of ordering was returned from the call to CMP, the compare with the values in guess and secret number. So a match expression is made up of arms. I think these are kind of like arms. An arm consists of a pattern to match against and what to do when it matches is it, and the code that should be run if the value given to the match uh, fits that arms pattern. Right, so this is the pattern to match against, and if the match is given a value, this is the value the match is given, fits that arms pattern. Like what code should be run if the value given to match, this is the value given to match, fits that arms pattern. Rust takes the value given to match and looks through each arms pattern in turn. Patterns and the match concept are powerful Rust features. They let you express a variety of situations your code might encounter, and they make sure you handle them all. So these features will be covered in detail in Chapter 6 and Chapter 19 respectively. Okay, so basically patterns and match construct. So let's walk you through an example with the match expression we use here. So say that the user has guessed 50 and the randomly generated secret number this time is 38. Right, so guess this 50 and then 38. 50 compared to 38. 50 is greater than 38. So you type 50 and 38 here, and between what should come greater than. So too big, it should say. When code compares 50 to 38, the same will greater than greater because 50 is greater than 38. And the match expression gets the ordering greater value and starts checking each arms pattern. It looks at the first pattern, sees the value ordering greater does not match ordering less, so it ignores the code in that arm and moves to the next arm. The next arm's pattern is ordering greater, which does match ordering greater. The associated code in that arm will execute and print too big to the screen. So the match expression ends after the first successful match, so it won't look at the last arm in this scenario. However, the code in listing 24 won't compile it. Let's try it. So expected string found integer. So because guess is a string, so you will want a string. So the core of the error says that there are mismatched types. Rust has a strong static type system. However, it also has type inference. And we wrote let mutable variable guess. Rust was able to infer that guess should be a string and didn't make us write the type. So we can actually see how you can actually write the type, I think. For example, you can actually just say colon and then string and it will just work. But if you say str or something like that, it might not work. It'll say what is str, similar name exists, something like that. Original diagnostic. Strange, just let's say strange. Strange is not a type that we can understand. Stuck with a similar name exists string. That's all it can say for now. Um, so, yep, and cannot find type strange in the scope, right? So you can tell string, then it's basically explicitly writing it down, or you can suck it. And but if you do colon, it will be a mistake because it will say passing the type for binding, so there was an error. So just leave it, and it will show, it will infer and show in the IDE, integrated development environment. So now it says so Rust was able to infer that it's a string. The secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. So 1 is the 32-bit number. Because it's 1 and 100, between 1 and 100, it's all positive, so it's all unsigned. Signed would mean negative, so unsigned 32-bit or 64-bit number as well as others. Unless otherwise specified, Rust defaults to 32-bit integer or number, which is the type of secret number unless you add the type information, right? So secret number you can see actually is 32-bit. So 32-bit integer. So unless you add type information as well, that would cause Rust to infer a different numerical type. The reason for the error is that Rust cannot compare a string and a number type. Ultimately, we want to convert the string the program reads as input into a number type, so we can compare it numerically to the secret number. So we do so by by adding this line to the main function, which is I think some conversion. Yes, so we trim any spaces, we parse it, we parse. I don't know why it's just parse. So let's see here. So after thing, we actually use this. We use the same thing. Um, we use the same name. I think this is called shadowing. I think this is possible in Rust. So after you say you guessed this, before that itself you can actually say um, let guess equal to. We say we need an unsigned 32-bit integer, and if we do this guess dot trim dot parse. Is there an integer into integer? No. Interesting. What does the parse do, I wonder? So from string, so traits from string, so it passes string into a return a value of this type. So if parsing succeeds, return the value inside OK. Otherwise, when the string is ill formatted, return an error specific to the insider. Basic usage with either the type that implements from string. So okay, so interesting. So can you also do the same for I don't know for bool? Okay, yeah, I think there is from string for bool also. So there is something saying from string, and then, or you can just say parse. Here it says from string, and yeah. So if you say parse and expect and give a message saying please type a number, please type a number, and now I think we should be good. Cargo run, and if you type ABC something, it says thread mean panic, and then please type a number, and then pass integer error kind invalid digit. Right? So if I say 1 too small, 84, so 90 too big, um, 68, so you win. Nice. So it does work now. I'll continue after in the next video. I'll see you next one. Bye bye.